Hey and welcome. Today we will solve Pascal's triangle interview question, so let's get into it. Examples are pretty much obvious. We will get a number which will indicate the height of triangle, and we are going to build a triangle level by level. So if we get 5 as a number, we need to produce a triangle with 5 levels. Here is the second example, and it just wants to hint us that even given 1 as height, it is so important to return the correct structure of triangle as a two-dimensional array. Let's see how we are going to solve this problem. As you saw in the question's description, the two edges of triangle has to be filled with ones as we build the triangle. That is a clear signal for us that every level we build, we might have ones as a first and last value of the array in that level. But for middle values, I realized that the animated GIF in the question's description is a bit misleading in terms of what we are going to deal with in code. Instead of looking at triangle like this, think about it like this. The triangle from questions descriptions shows us that every middle value comes from the sum of two values above it, and technically that is true. But in terms of the way we will represent a triangle in a 2D array, we have to deal with only index values within each level. And the question is how we are going to access those values within a two-dimensional array that we are going to produce. First of all, we will iterate over a given number and of course create the arrays for each level of that. Then we will fill first and last index of each level with 1, but starting from level 3, the middle values are going to be appear. And for that, of course, we will use the principle here and take the two above values. But look at here this time. In terms of a two-dimensional array, we only deal with indices. The JavaScript interpreter does not know what going up means. It just knows indices. So we are going up one level in the code. So going up one level in the code would translate to subtract 1 from whatever level we are in the main loop, then take the value before where we are, which means go left. Then we need to add it up with exactly the index above in the current index we are, just -1 in y-axis. That will give us what we need. And this will apply for all middle values as we go further in levels iteration. So all matters for us in here is just index values, because that is how we access elements in code. You see how we just divided a bigger problem into smaller sub-problems and eventually build up our answer? This is the core concept of dynamic programming, and that is what we exactly going to do. So let's jump into the code for implementing it. Here we are in Leetcode. First, we will initiate a result array. Then we will do an iteration over the given number rows. Within this iteration, initially we need to build an empty array for the level we are currently. Then we need to fill first and last index with 1, as how Pascal's triangle looks like. First index is easy, but last index is the ith value in every iteration. Just a bit of description here about first two levels. So for first level, we will put 1 in index 0, but we are in first level, so last index is also 0 for that array. It will be replaced. For second level, we will put 1 in index 0. The last index is index 1. We will put 1 in there too. From level 3 above, there will be empty indices in between to be filled. So you get the idea of how we build the result array for the first two levels. Then between those two manual updates of indices, we need an iteration that starts from index 1 and keeps iterating until it reaches ith index. Because remember, the ith index is for putting the last 1 in the array that we already manually do it in line 11 here. And now here's the moment of truth. For every index within this iteration, we will grab two values, that is in current index we are and the one before it, but from upper level of the triangle that we are building so far. With that, after this iteration, our array is ready to be returned. Now, if I run this, tests are passing, and if I submit, everything is fine here. Now let's jump into the slides for time and space complexity analysis. So the time complexity will be O of n in power of 2, because our outer loop will run n times, but our inner loop will also follow the given row counts and always run only 2 times less than row counts in each level. Why 2 times less? Those 2 is exactly the amount of manual work that we put for each level, the ones at the beginning and end. But we always take the worst case, so that is why O of n in power of 2. And the space complexity will be O of 1, because they expect us to generate an array. So that was it for this video. Thanks for watching, and please leave a like, comment and subscribe to the channel. I'll put a few more links about different playlists in the description for you to check it out. And finally, hope you enjoyed this video and stay tuned for the next one.